Yeah, good morning. This is Dr. Chander Pawar. I am working as the Associate Professor of Chemistry in Marri Laxman Reddy Institute of Technology and Management. As part of today's class, we will be discussing about remaining topics of water and treatment. Remaining topics are boiler internal treatment methods and external treatment method, followed by the reverse osmosis. So before going into these internal external treatment methods and reverse osmosis, let us quickly summarize what we have discussed in the last class. Basically, in the last class, we were discussing about the uh, boiler troubles. Boiler is a closed vessel which is specifically designed for the steam generation, followed by the heating and steam generation for the electricity production. So while generating the electricity, there are some troubles in the boiler. Majorly, those troubles are scale formation, sludge formation, priming and foaming, and caustic embrittlement and boiler corrosion. These are the major boiler troubles we were discussing in the last class. So when we talk about scale and sludge major problems in the boiler, scale is nothing but very hard and adhering coating which is formed inside the inner wall of the boiler, which cannot be removed easily with simple treatment methods unless we use some chemical treatment methods. And sludge is very simple definition, like loose and slimy precipitate formation inner wall of the on the inner wall of the boiler. So this sludge can be removed easily by simple chemical treatment methods, whereas scale cannot be removed easily. So these are the two major problems, scale and sludge. Apart from this, boiler corrosion. Boiler corrosion is nothing but degradation of boiler inner walls. Basically, corrosion, whenever it is initiated, it will keep on grows, and ultimately the boiler will be degraded or damaged. So to avoid that, what are the prevention methods and how it is caused, we have discussed. And there is one more important boiler trouble is caustic embrittlement. Caustic embrittlement is nothing but sodium carbonate which is there in the feeded soft water. This, when sodium carbonate further dissociated into sodium hydroxide, NaOH. This NaOH is referred as a caustic. Caustic is nothing but alkaline material. So NaOH, alkaline material, basic nature. So whatever the hairy cracks or wide spaces are there in the boiler, manufacturing defects or any minute issues are there. So whatever the sodium hydroxide formed while boiling the boiler water, so this sodium hydroxide is entering into the wide space or hairy cracks or minute issue, defects, and then it will leads to the damage of the boiler. So that is why we are calling it as a boiler embrittlement or caustic embrittlement. Caustic brittlement is related to something crack formation or damage or something breakage. So embrittlement. So these are the major issues which we have discussed. Now let us briefly discuss about how to overcome those issues. So there are several methods for the treatment of boiler. So major treatment methods are internal here we can see internal treatment methods are generally followed by the blow down operation. Blow down operation is nothing but we will be sending a huge high pressure steam, and without high pressure steam, whatever the scale or sludge or impurities are there inside the boiler, those will be easily blow down or wiped out. So that's what blow down operation works, and so that an accumulated sludge is removed. And important internal conditioning treatment methods are three types. So internal treatment, there are two methods: internal treatment methods, external treatment method. So include in the part of when we talk about internal treatment methods, there are three methods. There is three internal treatment method is of three types. So first one is Calgon conditioning. Yeah, as it is mentioned here, Calgon conditioning involves in addition of Calgon to a boiler water. What is calgon first of all? Calgon is nothing but sodium hexametaphosphate. We can see the formula here, Na, sorry, Na2, Na4, PO3, taken 6. This is the sodium hexametaphosphate. So there are 6 phosphate groups and 6 sodium groups. So that's why we are calling it as a sodium hexametaphosphate, which is a good chemical which can be used to remove the calciums. You know, calcium is in the form of hardness of water. So basically when we talk about calgon, calcium gone, what we are doing? Basically, whatever the calcium based salts are there in the boiler water, so we are removing the calcium based salts from the water. So that's why we are calling it as a calgon conditioning. So now let us see here how this sodium hexametaphosphate works. Sodium hexametaphosphate, whatever I wrote here, this will be dissociated into, further dissociated into sodium ion plus sodium phosphate, Na4, P6, O18, 2 minus charge. So this dissociated sodium will be further interacted with the permanent hardness causing salt, that is nothing but calcium sulfate. Here we can see calcium sulfate. What is the salt responsible for the permanent hardness? Calcium sulfate. Calcium sulfate, CaSO4. Now, how this calcium sulfate can be removed? By using the calgon. What's happening here? So sodium, calcium sulfate will be dissociated into Ca2 plus ions plus SO4 2 minus ions. So this calcium will be combined with phosphate. Here we can see calcium 2 replaced with sodium. So calcium, so phosphate group of sodium hexametaphosphate has been conjugated with calcium phosphate and converted into calcium phosphate. Whatever the sulfate group is there, that sulfate group will be interacted with sodium and giving the byproduct as sodium sulfate. Now let us see whatever the permanent hardness causing salt is there, calcium sulfate, that has been interacted with phosphate group, so calcium phosphate form, and sulfate group interacted with sodium and sodium sulfate byproduct form. Now let us see whatever the byproduct, whatever the main causing salt calcium sulfate is there, that ultimately with the help of calcium hexametaphosphate that has been dissociated. That means whatever the permanent hardness causing calcium sulfate is there, that has been removed from the boiler feeded water. So this is how this calcium hexametaphosphate works. Now let us see the second method. Second internal treatment method is phosphate conditioning. Very simple phosphate conditioning, as we have discussed it like calgon conditioning. Phosphate conditioning, basically we are using the sodium phosphates. Earlier it is sodium hexametaphosphate. Here so trisodium phosphate. Yeah, we can see the formula of trisodium phosphate here. Na3, PO4, sodium triphosphate, 3 moles of sodium and phosphate group PO4. This trisodium phosphate, how it is helping to remove the permanent hardness causing salts. For example, when we talk about this calcium chloride, CaCl2, and magnesium sulfate, both the salts are permanent hardness causing salts which are there in the boiler feed water. Now what's happening when we take about this calcium chloride or magnesium sulfate, MgSO4, what's happening? This sulfate ion, magnesium ion, this calcium ion and chloride ions, all 4 ions will be dissociated. And how they are conjugating, how they are making a complex? Whatever the calcium is there from the calcium chloride, this calcium is combining with the phosphate of sodium triphosphate here, and this chlorine going as a byproduct with NaCl. Now let us see whatever the calcium chloride is there, this calcium chloride has been dissociated into 2 parts. dissociated into two parts. Calcium combines with phosphate of sodium triphosphate, and chlorine combines with sodium, and it is giving sodium chloride as a byproduct. Let us see the second example. Magnesium sulfate. Whatever the magnesium metal ion is there, that is conjugated with the phosphate of sodium triphosphate, and it is giving the magnesium phosphate. Here earlier case calcium phosphate. Trisodium phosphate has been converted into calcium phosphate. Now in this magnesium sulfate case, magnesium has been complexed with the phosphate and magnesium phosphate group has been formed. And whatever the sulfate ion is there, that sulfate ion has been conjugated with sodium of this trisodium phosphate, and ultimately it is giving the sodium sulfate. So now when we talk about how it is dissociating the permanent hardness causing, calcium combined with phosphate group of trisodium phosphate and forming the calcium phosphate. Magnesium sulfate salt has been dissociated into magnesium and sulfate ion Mg2 plus and SO4 2 minus. This magnesium has been combined with the phosphate of trisodium phosphate and magnesium phosphate group formed, and sulfate has been removed in the form of sodium sulfate. So whatever the permanent hardness causing salts are there, that is calcium chloride, magnesium sulfate, those has been converted into calcium phosphate, magnesium phosphate, and byproducts are in the first case sodium chloride, second case sodium sulfate. So ultimately these salts has been dissociated into several byproducts. With that, permanent hardness causing salts are completely dissociated and removed from the boiler feed water. Now generally trisodium phosphate Na3PO4 and disodium phosphate, these are the two salts which are generally used for recommended for the phosphate conditioning. Trisodium phosphate is too alkaline, used for the treatment of too acidic water, and disodium phosphate, that is Na2HPO4, that is weakly alkaline and used for the treatment of weakly acidic water. So these are the two major salts which we are using for the phosphate conditioning treatment. Now after finishing this phosphate conditioning, there is a third internal treatment method, that's nothing but Calgon conditioning, as it is mentioned here, 3 Calgon condition, colloidal conditioning. Colloidal conditioning is nothing but very simple. There is no much chemical reaction involvement or chemical usage involved in this. So basically colloidal conditioning, organic substances like kerosene, we all know that kerosene is the byproduct of petrol, diesel. When we do the refining or fractional distillation of a crude oil, so kerosene is one of the byproduct. So kerosene, tannin, agar agar. Tannin is nothing but an organic hydrocarbon, protein hydrocarbon molecule, and agar agar is nothing but a jelly like substance, jelly like organic substance. So by using these three kind of organic substances, we can remove whatever the sludge formed inside the boiler. So basically how it works, so whenever we are using doing some painting or these that house purpose, so basically our hands become painted and it will be very difficult to remove. So we use turpentine and some other kerosene or diesel related materials. With that whatever the paint stains are there on our hands, that will be easily removed. So similarly here, by adding these organic substances like kerosene, tannin, agar agar, so whatever the loose and slimy precipitate formation is there inside the boiler feed water, that will be easily removed by the adding these three organic substances. So basically these substances gets coated over the scale forming precipitate and gives a loose and non-sticky precipitate which can be removed by the blow down operation. As I told you, blow down operation is nothing but as we can see here, there is a steam generating chamber. So huge pressure with huge steam with huge pressure will be developed, and whatever the sludge and scale boiler troubles are there in the boiler, inner wall of the boiler, that will be high pressure steam will be sent, and with that high pressure, whatever the precipitate or whatever the scale and sludge are there, those will be wiped out. This is basically simple blowdown process. Now, after discussing the three internal treatment methods, let us go into the final method, that is external treatment method. External treatment method, we are not doing any treatment on the boiler surface. Basically, before feeding the water into the boiler, we are treating the feeding water. How we are treating and why we need to treat? Whatever the permanent hardness causing salts are there in the water, those will be removed prior to loading the or feeding the water into the boiler. So this process is nothing but ion exchange process. What is ion exchange process is further called as deionization or demineralization process. Just name itself, deionization, removal of ions; demineralization, removal of minerals or any salts from the water. So deionized water or demineralized water is free from the any salts. That means water is much more soft. That soft water, whatever upon feeding into the boiler, which we can prevent the scale and sludge and caustic embrittlement and all other boiler troubles. Now, how to purify or how to make the water soft? How to make the water soft? By using ion exchange method before feeding it into boiler. Now, what is ion exchange resin? There is a concept called ion exchange resin. Ion exchange resin are nothing but filters. These filters are nothing but insoluble. Yes, obviously it should be insoluble, as we use the AquaGuard, Kent, all these water purifier in our domestic purpose. There will be a filter which will be removing or functioning all the time to remove the impurities or unwanted salts which are there in the water, and then the finally potable water which we are drinking. We all know that AquaGuard and Kent are the best RO systems. Now here we can see whatever the filters are there in the this ion exchange process. Those filters are resins we are calling, and those are insoluble. Obviously that should not be dissolved. And cross-linked long chain organic polymers. So what are those filters or resins? Cross-linked long chain organic polymers with micron size porosity. Yes, micron size 10 to the raise minus 6, 0.00001 micron, 10 to the raise minus 6 micron. Nano 10 to the raise minus 9, pico 10 to the raise minus 12, femto 10 to the raise minus 15. Here pico 10 to the raise minus 6. Okay, micron sized, micrometer porous filters or resins. Now these functional or groups are filters are having functional group. If it is a cation exchange resin or filter, it is releasing the cations, that is nothing but protons, H plus ions. If it is a anion exchange resin or anion exchange filters, that will be releasing OH minus ions. You can see here, these are two types of resins. First one is cation exchange resin, which releases the H plus ion; anion exchange resin, which releases OH minus ion, which is acidic, which is basic nature. Now, a resin with acidic functional group are exchanging H plus ions with other cations. That means the beauty is cation to cation, means positive charge ion to positive charge ion only. Here statement is very clear. Resins with acidic functional group exchanging H plus ions, cation, with other cations. See, the statement is very crystal clear. That means exchange between cation resin to cation of salt. Whatever the positive ion from the filter or resin, that positively charged cation will be exchanged with any other salts which are there in the water. Very simple. Similarly, anion resins. Anion resins with basic functional groups are exchanging OH minus ions with other anions. OH minus ion is anion, and other anion means from the salt, and this OH minus is from the resin. resin ka OH minus ion has been replaced with other OH minus ion or any other anion from the salt. Salt in the sense water. Now let us go into details. So basically resins are two types: cation exchange resin, anion exchange resin. Now let us have some brief details about cation exchange resin. Cation exchange resins are styrene divinyl benzene copolymers. What are the cation exchange resins? Styrene divinyl benzene copolymer. It's a chemical compound which is helping for the cation exchange resin preparation. Now such resins have SO3 sulfate ion, SO3H, acidic ion, COOH, OH, phenolic group or ionizable groups which are part of the cation exchange resin. Now, these resins exchange the cationic portion of minerals by their hydrogen atom. They are known as the cation exchangers. Simply, how to understand this statement? Let us see. Let us see with examples. Now, here when we talk about the first example, these whatever this left hand side are there, RH group containing 2 RH plus RH, 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 all these are the resins. Resins are filters. FILTERS, filters. Okay, these are the filters. Now whatever this right hand side is there, these salts: calcium bicarbonate, magnesium bicarbonate, calcium chloride, magnesium sulfate, calcium sulfate. What are these? All these are the hardness causing salts. So which salt responsible for the temporary hardness and permanent hardness? This red two, calcium bicarbonate and magnesium bicarbonate, temporary hardness causing salts. When we talk about this calcium chloride, magnesium sulfate, calcium sulfate, all these are the permanent hardness causing salts. Okay, salt which is there in the feeded water. Now we are going to feed the water into the boiler. Okay, so now how these salts can be removed from the water to make the water soft before feeding into the boiler. Now whatever the resin is there, these are the resins. Whatever the resin, RH, how it is dissociated? RH gives rise to R minus plus H plus. Okay, so what is coming out from the resin? H plus, proton. Proton is nothing but here cation. Now let us see the salt. What is the salt? Calcium bicarbonate. How this can be dissociated? Ca2 plus HCO3 2 minus. Okay, Ca2 plus. Now let us see. This calcium is cation from the salt which is there in the water. This calcium from the calcium bicarbonate salt has been, now whatever the calcium 2 plus ion is there, 2 plus, and this H plus from the resin, H plus has been replaced with Ca plus, and this H plus is going with the water. Now let us see. RCA. So exchange between what? Resin proton and calcium 2 plus. So calcium 2 plus is cation and H plus proton is cation. So resin ka proton has been replaced with the salt ka cation. Positive charge to positive charge only. That is why it is called as ion exchange. What kind of ion exchange? Cation exchange resin, or cation exchange process. Okay, simply resin ka cation, that is nothing but proton H plus ion, has been replaced with calcium 2 plus cation from the salt, and simply resin has become R2Ca and there is a byproduct. Simple. So exchange has been happened between positively charged proton cation to positively charged calcium 2 plus. So cation to cation exchange has been taking place. That is why we are calling it as cation exchange resin. Very simple. Similarly, When we talk about other examples, here magnesium, Mg2 plus, Mg2 plus has been replaced with H plus, H plus from the resin. This cation exchange होगा. So R2Mg, that's the resin which is conjugated with magnesium, and there is byproduct H2CO3. Again here the exchange has been taken from the between Mg2 plus cation to H plus proton, that is which is a cation. So cation to cation exchange. Simply, that's why we are calling it as a cation exchange resin. That is for in the case of two temporary hardness causing salts, calcium bicarbonate and magnesium bicarbonate. When we talk about permanent hardness causing salt, that is calcium chloride. Calcium chloride can be dissociated into CaCl2 gives rise to Ca2 plus Cl minus, 2Cl minus. This calcium 2 plus cation has been replaced with resin ka proton, cation H plus. So Ca comes here and this proton with HCl chlorine. So HCl byproduct and resin is proton eliminate गया और calcium से replace हो गया. So this is a resin and this is the byproduct. Very simple. Similarly, with the magnesium chloride, which is a permanent hardness causing salt, and magnesium sulfate, another permanent hardness causing salt, and calcium sulfate, another permanent hardness causing salt. So resin ka cation has been replaced with salt based cations. Very simple. That's why we are calling it as a cation exchange resin. Now let us see anion exchange resin. Anion exchange resins are phenol formaldehyde or amine formaldehyde copolymers. Now let us see what are the examples for these resins. Amine group NH2, NHCH3 and again tertiary methylamine and OH groups. These are the some of the basic anion groups which are present with the anion exchange resins. Now let us see. They exchange the anionic portion of minerals and they are known as anion exchange resin exchanger. To understand it better, let us see with example. First example is ROH, which is a resin. These are the resins. Okay. ROH, all these three are the resins. And these are the some acidic salts or acids which are there in the water. What's happening now? When we talk about first case, ROH, this is a resin. This resin HCl, H plus Cl minus, ROH minus. This OH minus anion has been replaced with another anion, that is Cl minus, chloride ion, negative charge anion. Here OH minus negative charge anion. So OH minus ion has been replaced with Cl minus ion. So in between the exchange is taking place between negatively charged ion to negative charged ion. So that is OH minus of resin and Cl minus of a hydrochloric acid. So what we are getting? RCl and then byproduct is H2O. See, whatever the resin is there, resin containing OH is there, OH minus anion has been replaced with Cl minus ion and there is the byproduct. Let us see the beauty of this anion exchange resin. Anion from the resin or filter has been replaced with chloride anion. So exchange has been taken place between anion to anion. That's why we are calling it as anion exchange resin. Now let us see other examples. ROH with the sulfuric acid, in earlier case hydrochloric acid, with the now it is sulfuric acid. Same, what is happening? sulfate ion SO4 2 minus anion has been replaced with OH of the resin, and we are getting R2SO4 and water as a byproduct. Similarly, in carbonic acid also replaced and byproduct as water. Simple. This is the anion exchange process. So basically, when we recall the ion exchange process is external treatment process. Basically, cation exchange resins and anion exchange resins are involved in this. So anion exchange resins, anion of resin and anion from any acid has been replaced. So anion to anion, negative charge to negative charge ion has been exchanged. When we talk about cation exchange resins, cation of a resin and cation from any salt which are there in the water. So cation, that is positive charge to positive charge, exchange has been taking place. And finally, whatever the permanent hardness or temporary hardness causing salts are there, those will be eliminated. That's the main purpose of our ion exchange process. Now, final topic is of our water and treatment is RO system. RO system is nothing but reverse osmosis. How does it works? We all use the Kent, AquaGuard, this, that, many RO systems in our domestic purpose, but we never know that what kind of mechanism is happening in that RO system, reverse osmosis. Before going into the reverse osmosis, let us try to understand what is osmosis. Osmosis is nothing but by virtue or natural phenomena or spontaneous phenomena, any material or any solvent flows from lower concentration to higher concentration. General phenomena of osmosis is flow of any liquid from lower concentration to higher concentration. That is the general phenomena. So opposite to that, flow of any material from high concentration to low concentration. Reverse osmosis is not happening just like virtue, by virtue or spontaneously. It's not a natural process. Natural process is osmosis, low concentration to high concentration. Whereas reverse osmosis is not a natural process. Flow of high concentration to low concentration. How it is happening? It is happening by applying the external pressure. Let us see here. Osmosis is the phenomena by virtue of flow of solvent takes place from region of low concentration to high concentration. Very straightforward definition. But when we talk about reverse osmosis, it needs some pressure. Yeah, as it is mentioned here in this picture. How much pressure? 20 to 40 kg per centimeter cube. This much of pressure we need to happen or to flow the ions from high concentration to low concentration. We have to apply the pressure. How much pressure? 20 to 40 kg per centimeter cube. This much of pressure we have to apply. Let us try it, try to understand it in better way. Let us see. There is a chamber we can see here, and on the top layer there is a piston, as it is mentioned here, piston. Piston is for the pressure applying purpose, and there is a SPM. SPM is nothing but semi-permeable membrane. As we talked earlier, microporous structure or microporous membrane. SPM is nothing but semi-permeable membrane which is having micron size pores. So what will happen? There is a seawater. Seawater is nothing but high concentration water. So how it is flowing? We will be applying some pressure on the top of this seawater or concentrated water. When we apply this pressure by using this piston, what will happen? The ion flows from high concentration to low concentration. That's why reverse osmosis is not happening naturally or spontaneously. We are externally applying some pressure through the help of piston, okay, and then high concentration side, that is from the seawater level to pure water, low concentration, high concentration to low concentration ion water flows through what? Through SPM, semi-permeable membrane. So whatever the hardness causing salts are there from the seawater or high concentration water, those will be separated with SPM, semi-permeable membrane, micron size porous membrane. And finally at the bottom chamber we will be collecting the salt-free water. That salt-free water is nothing but pure water, which we can use for the drinking purpose. Very simple. Now let us see reverse osmosis. Before reverse osmosis, osmosis is the natural process. Without any pressure, what will happen? Low concentration to high concentration water flows. That is osmosis. Whereas reverse osmosis, it is not happening spontaneously or naturally or simply like that. So we are applying some pressure from high concentration side of water or any sample. With the help of pressure, this much of pressure we are putting. What will happen? Whatever the ions are there, those will be separated with the help of semi-permeable membrane, and finally we will be collecting the pure water for the drinking. This is how reverse osmosis mechanism takes place, and finally we will be collecting the drinking water. This is the main purpose of reverse osmosis. Yeah, there is a video. Yeah, thank you very much. I hope you understand well this water and treatment. If any questions, I am ready to clarify your queries. Okay, thank you very much.